Good afternoon, everyone. Uh, Thank you for joining us for this month's AI Live. As some of you all know, the AI Lives are monthly workshops that Coding and More organizes, where everybody and anybody who's interested is free to join. And we talk about all cool things happening in AI. And today we have with us Miss Nidhi Ashok. She's actually a mentor at Coding and More as well. So we're very happy to have one of our own today. Miss, I'll just tell you a little bit about Miss Nidhi, and then maybe if she wants to share more, she can share for herself. If y'all have questions during the session, then please put them into the chat, or you can raise your virtual hand or the emoji on Zoom. And we will also be sharing this recording of this live workshop in our newsletter as well for this month. All right, so a little bit about Miss Nidhi. Miss Nidhi has a bachelor's degree in computer science engineering. She has a fancy certificate in big data analytics. She has a post graduation in data science. She's worked for lots of big companies. And she's also been an RA, a research assistant at the University of East Anglia. And now she is mentoring lots of kids, just like y'all. She's also working on projects that she cares about the most and she feels passionate about. So we're very happy and lucky to have her with Coding and More. Miss Nidhi, over to you.
Hi everyone, good afternoon. Are you as excited as I am to share about natural language processing today?
Yes, very.
Thank you, Ridhima, for the introduction. I think I'm done with that, so I won't add anything more. It was lovely what you've done already. So I'll get started with the slides directly. Let me share my screen. Let me know once you can see it.
Yes, we can see.
Okay. Okay, so natural language processing, I'm sure you've heard this a lot. Also, I think you've heard mostly what it's applied at rather than the technology itself. So you would have heard ChatGPT, you would have heard Grammarly, you would have heard Siri, of course, and Google Assistant. So we'll see what exactly goes behind all of these. So our agenda is to understand the basics so that we can then come up with how these applications work. So I'll have a few questions for you in the beginning. So you will be answering my questions and you will be teaching me NLP in the first place. So let's start and let's try to find out what is natural language processing. So there's a scenario before that. There is a small comic over here. So if we did time travel and we went back to some year, and then there's this guy who tries to ask another person, and that person has no clue what this person is speaking. So because everybody does not speak English, so there's a communication barrier over here. Will you be in the same situation if you try to talk to your computer, or will it understand you?
You need a common language, right? If
Exactly. So basically, communication is one of the key goals with our natural language processing. So what does a computer understand? What language is it that the computer understands? That will be your binary numbers. It just understands ones and zeros, not even your natural numbers or whole numbers. It only understands 1 and 0 at the core of it. So how do we communicate with the computer then? By converting everything we know into zeros and ones. But is this communication just one way? Do we only talk to the computer, or does computer talk back to us? Of course, Siri answers us, right? Or Alexa answers us, right? So it has to go the other way around as well. We need to have answers from there that we will understand. And if it just keeps on saying 0000 or 111, obviously we won't get it. So for that, what do we have? We have higher level programming languages. But these higher level programming languages acts more like an interface, and it's not just specifically which converts directly to our languages. Our languages is a natural language. I'm not keeping it specific to English. I'm also saying it whatever language has been worked on right now, like Spanish, Chinese, Korean, all of these, Hindi for that matter, all these languages have been converted now. So we'll use advanced programming languages to process this. So obviously, when these are done, it sure is easy to talk to the computer, right? You don't have to say just 00 or 11, or you don't even have to worry about what would 1 or 2 stand as in a binary code. So next is, what is the purpose behind this? Okay, we talk to the computer, but what do we do then? What is the point of even talking to the computer, right? So for that, it's about how our knowledge is communicated in this society, basically. What do you think? Like, why do you go to schools? Other than to play and talk with your friends?
Like to learn what's going on around the world.
Exactly. So all these, you learn all these from even books. Your teacher teaches it, right? She writes on the board. Even if it's on online, she shares PPTs. And then there is written documentation in general. So that is how you learn. And then all these are stored as well. So storing the knowledge is also a goal. So sharing the knowledge and storing the knowledge is the goal. And it is easier to obviously store it in a computer rather than storing it in a different places. Like libraries and archives are a good place to store your knowledge, but it is limited access. But if it's on the internet, everybody has it. Just like how ChatGPT is trained on the whole of internet, the similar way we have access to knowledge over internet. So next, in the end, what will be the ultimate outcome, which is your scientific understanding? So what is science basically? Anybody can answer me this question. What is science?
And don't Google it.
Yes.
Science is like what happens all around the world, like how everything around the world works.
Very well put. So it is basically just what's happening around the world. So for us to understand this further, to manipulate this, to make the best use of the world around us, we do a certain experiments. We have our own theories. We test all these theories, and that's your whole idea of science. So wouldn't be it easier for, if you can automate a computer to understand and do all this for you, while you can get busy doing other things? So for that reason, we need our natural language processing so that your computer reduces your work. So end of the day, when it comes to reasons for why natural language processing is important, it is to communicate, it is to learn, and it is to have advanced scientific understanding. So next, this is the definition. So this is, in end of the day, the definition will come up to this. Natural language processing is nothing but an artificial intelligence technology which enhances computers' ability to interpret, manipulate, and comprehend human language. Why do we need this? Because, well, it would be really nice to know what weather it is in Ireland before you travel there. So all these kind of information is gathered because computer can understand our language. So where can NLP be used? So the places where NLP and application of NLP happens is this. So we have seen Grammarly, we have all used Word, We have used PowerPoint presentations. You remember, I'm not sure it's there right now, but earlier people who've used the word in, say, 2010s and 2000, you remember the small clippy thing? So that was like the beginning of artificial intelligence, where an assistant was deployed. So even that would be your application of natural language processing. So then your Google also employs natural language processing. Then you have your voice assistants, which is Alexa, you have Siri, and then news feeds. Obviously, news feeds is basically, it is a classification. So when you like something, you do see that Facebook or any other social media platforms that you're using, it shows you what you like again and again. It shows you related posts to these again and again. This also comes under natural language processing itself. And then you have translation systems. So before, you would have to learn the language to go and try to make it in a country, but now you can actually go there. It's okay, you have time enough, the internet's fast enough, you can just type in what you want to say in English. The Google Translator immediately shows you what can be said in that language. Ma'am, anything? I couldn't hear you, Supriya ma'am.
No, I'm sorry. I'm good.
Okay. So are we good so far? We know what do we know what natural language processing is right now? Do we understand it? Any questions about this so far? Okay, so now I'll move on to how this whole thing is done. So how can it be applied? So there are various natural language processing tools like bag of words model, Ngram model, there's word representation, there's parts of speech tagging, word embedding, transformers, and then our famous large language models right now. Essentially, large language models are transformers itself, but it is a separate category. I have put it in a separate category because the scale is very different. The size of large language models is very different, and its use and application differs from transformers. Okay. So this is something that's very, very basic in natural language processing that we need to know. So now if you and I are reading just this slide, for example, machines cannot process raw text directly. We just understand this when we read this. It's just like a reflex action that goes on our brain. The brain processes it immediately. But that's not the case with the computer. We have to teach it how it's done. So if you give machines cannot process raw text directly to this sentence to the computer, what has to be done and how is it supposed to be given before it does any processing is a first step. So you cannot directly give this sentence and expect a output. What you need to do is you have to change this. So you have to bring this down to the level of computer's understanding. So what you do is you break the sentence down. You first make it into it's broken down into something called as tokens. So each token can be a word, like just machines can be one token. The space between machines and cannot can be a token. The comma, the exclamatory marks, all these will become a token. And other than that, we'll have tokens to indicate the beginning of a sentence and the end of a sentence. So all of this process is called tokenization. So basically, you're splitting the sentence into words, subwords, symbols. Then you're mapping these words into numbers. So before we go into directly doing this into zeros and ones, we convert that into mathematical numbers. And then these are converted into binary numbers that the computer understands. So for that, we make this mapping relation behind the scenes. And neural network models which takes only square matrices. But all your sentences are not of the same size. I can just say, hi, I'm Nidhi. I can say, hi, I'm Nidhi. I am a teacher in coding and more. Or I can say, hi, I'm Nidhi. I'm a teacher at coding and more. I'm also a mentor. So this will be same sentence of 3 different sizes. And I want it to be processed at the same time. So what will I do? I'll have to make it of the same size. To do that, I add some extra the spaces and convert them into tokens so that everything is of the same size and the neural network does not get confused. So this is the tokenization section. Simply put, if you have to make the computer understand what you're trying to say to it, you just have to go through a lot of process. The first thing is to break your sentence down into words and then tell the computer what are words, what are subwords, what are the commas, what are the spaces. It's the first step you do. So transformers. So at the level of tokenization, I would like to stop sharing and I'll show you how exactly this process happens. Okay. Let me show you a piece of code which will kind of give us familiarity as to how this happens. Let me know once you can see my screen. Yes. Okay. So now you see this code. Let's say there are about 13 blocks over here. And on an average, even if there's, say, 5 lines of code per block, then just to identify which language this is, I'm just saying just to identify which language this is, it takes so many lines of codes. So here, basically what I've done is I have French, Russian, German, Italian, Spanish. These are all my data. So I've taken different sentences, a lot of words in all these languages, and I've stored it into a variable. Then what I do next is basically try to find out what are the frequent words. So when it comes to finding out frequent words, we know that to identify, so if I say today is Ridhima's happy birthday and there is a party. So in this sentence, our brain immediately understands happy birthday and party are important. The rest of the words in the sentence do not matter to us to recognize. So what we do is we just do the same for the computer. We only pick the important words. So the others are frequent words, which is like and, the, if, all these connectors, these words will not be as important. So what we do is we kind of call them stop words and we try to get rid of this. So we take out all these and then we split the words and we have the frequency text over here for every language. See, if you see encourage over here, it's just one, parlor one. So it's just has the frequency of this text. So this kind of gives you an idea. When you have these longer words, it is easier to identify for the computer, okay, this word belongs to this particular language. So I can say this is French. Next.
The computer has sorted it out?
Yeah, so I've sorted. So I've given it, see here, I've given sorted words. So I've sorted it according to the, this one, frequency of words. And the most frequent words, I've taken it off and I've just kept the top frequent words.
How did you identify the important words from the frequent words? Did you actually have to hard code it?
Yes, this is hard coded. So what I did exactly in this case is basically, first of all, every single word's frequency is calculated. So if you see, when you give a huge story per se, then the words like the, if, etc., will be a lot. So the number of words for these like frequency will be high. So what I do is see, this is why it's reverse over here. So I just pick out those that are least frequent. Then those words that are least frequent will be like the bigger ones. So you have specific words like dialogue. If you come to see, there is like nombres and nombrius and respondre. All these will be longer words, which technically in that text will be less frequent compared to your and the, etc. So you just take out these words. And then this is basically an n-gram model. So n-gram model is, if there is one word, it sees one word next to it, one word previous to it, and it identifies what the sentence might mean. So that's how n-gram works. It can be 2 gram, 3 gram, or 4 gram. So it will take either 2 words before it to understand what's going on, or 3 words before, or 4 words before. So that's how your n-gram models work. You know, in our first AI module itself, the first one that we do, there's this one, there are these 2 boxes, and we write down a lot of training sentences into it. And then we try to do the prediction. So that is your bag of words model or n-gram model. That is the basic model that's working behind this. So that is how it recognizes, okay, you do the classification, right? Or the sentiment analysis. So that is how this works. Then you match the score kind of, so if you will have a scorecard, so when you have all these frequent words out there, and then a new sentence or a new classification text is given by you as an input, it'll do the same frequency calculation on that one. That will have a score, and then it'll compare it with these scores. Whether it'll match with English, it might match with Spanish, it might match with any of this. And based on that, it just classifies. So higher the score that matches with these frequency, the classification happens. This is the most primitive way to do it. This is how it was done before. But right now with transformers and everything, this is not so difficult at all. The whole idea behind that changed. That's why I wanted to go through this code so that you get an idea as to how complicated this was before. So now what I would like to do is I'll show you how it's done currently. So 1 second, let me stop sharing and reshare.
Anybody has a question so far? Carry
No,
on.
miss.
Okay. Yeah, carry on, Nidhi. Sorry.
Okay. So I'll show this. So now this is how your transformer works. This is your Python programming. In Python, I'm pretty sure you know there are something called as packages. So in these packages are already available, it's like available ingredients in your shop. So you go buy these and then you decide what to do with it. So similarly, transformers is a package. So you install these packages, which is required, and then this is how simplified it has become because of transformer models, whose architecture I'll explain in a minute, but I'd like to show how this works. So you just import this, you call an object, like you call a variable, you assign it a pipeline, you say you want to do the translation, you name the model, like whatever model you've picked from Hugging Face, you just name the model, and then you call the translator in the brackets, you pass what you want, just a sentence, and you ask it to translate. And this is a course produced by Hugging Face. So it has translated the sentence for you. Similarly, I wanted this English sentence. This course teaches natural language processing in Spanish. So, este curso ensala el % del lenguaje natural. There it is. It just took us 2 sentences to do the whole thing, because transformer model works in that way and Hugging Face in specifically works in that way. It has done everything from the splitting, from the tokenization, everything on its own. We don't have to work for that.
But the transformer must have been coded to do that, right?
The transformers, the package itself, the transformers package that is designed, the architecture is designed in such a way that it has all the coding beforehand. We don't need to worry about it. We just have to call an object, assign the checkpoint that you, whatever task you want to do. This is specifically for translation. But if you want to do any other kind of, let's just go to Hugging Faces. Hugging Face, I'll show you.
And what is Hugging Face, Nidhi? Can you explain that?
So Hugging Face is a platform which is very, very ardently believes in open source artificial intelligence tools. So all these are basically tools that is present, specifically transformer models especially, and that too for natural language processing, they are hands down the best. So what happens here is basically, this is when you have a account, this is where you land up at. This is your page. And then if you want to do like similarly how I showed in this case, if you want to find out what is the model that you want to use, so what you do is you go to the models section over here, and then so our tasks is natural language processing, but then as you can see, similarly, we have multimodal, computer vision, audio, which is text to speech, speech to text, audio, and there is reinforcement learning and tabular classifications as well. So tabular classification regression is something like Excel. So now in natural language processing, these are the major tasks that you can do. Text classification, which is like your sentiment analysis, good or bad, not positive, neutral, negative, these kind of tasks that you can do using text classification. So here, let's say if you want to do text classification, you go here. This is your model that's available. You choose the model. So I would go with Distilbert because this is Hugging Face own transformer. So here it tells you what exactly this is, how it has to work, and what can be done. Even it shows you an example code. So you'll just have to train your piece of code based on this, your idea, your task. And you just call that model, like similarly you just call so here they have used a tokenizer, which is like further when you try to fine tune models and all that comes to that place, but you don't even need to do that. You can just call model, and then you can assign the model to it, the basic step, the first step of it. So as a learner, as a beginner, you do not have to worry about the background tokenizer and all that. All you have to do is just understand which model works for me with which, how do I understand the model cards? How do I apply this in your program? So this is what you'll have to focus in the beginning. Later, you can get into fine tuning and how you can make it more helpful for you. I can see Supriya ma'am's face, so I'll just
Ask a question
clarify.
or
Yes.
finish, and then I'll ask you the question. Finish.
I like to clarify one thing about this so far that I have explained. So there is something called as transfer learning, which is the key core principle that Hugging Face works on. So what happens now, I'm sure you're all students of artificial intelligence, so you've collected your own data, you've tried to train your own model, you've tried to get the output, you've tried to manage the accuracies and everything. But I'll tell you what, if you have no data at all, but you go to Hugging Face, you find a model the task that you want to do. For example, you want to do sentiment analysis. You have no data of your own at all. So what you can do here is sentiment analysis is already trained on a huge corpus. It's trained on Amazon's corpus, it's trained on Flipkart's corpus, it's trained on your Google reviews corpus. So you have various corpus like this. So it's already trained. It knows to do the sentiment analysis. So if you can directly go blindly take that model and use it to do your project. So you can directly take the input from the application, run it through the model, give the output. But the catch is, here it is trained on everything in the world. So it doesn't know exactly what you want. To tell it what exactly you want, you have to show some examples for it. So if there is a model that's been trained on, say, Flipkart, Amazon, Google reviews, and Yelp and whatnot, there are everywhere these reviews are there. It's been trained on all of this. But all you want to do is to find out whether the ice cream shop's flavors are good or not. Which is the best flavor? Like this, let's say there is a particular flavor that ice cream shop has released, and people have gone and tested it. All you want to do is try to find out this. So for the model to understand that it has to only do this, you use a few sentences. So these models, let's say for the scale of it, 1000, say it's just used 1000 sentences as its base. So you take 2 sentences to tell it, this is exactly what you need to focus on. This is like you're putting a spotlight on it. Anything that's in the spotlight, you only focus on that. The other things around is just noise. So when you tell the model that, okay, this is only the thing that I need to focus on, it only focuses on that. That is why you specifically use the data to tell the model, this is what you're looking for. So that's how your basic transfer learning works. And Hugging Face is a platform that provides you this package. There are many companies that you can use all these models from. But Hugging Face is one platform which has a lot of companies. Even NASA has its data set on this. IBM has its data set on it. Facebook has its data set and models on it. So you get to use all these amazing models to do your work through Hugging Face and for free of cost.
And the data sets that each model is trained on, you can see that, like, when you spoke about the sentiment analysis, it tells you, and when you put a spotlight, second question is, does a spotlight have to be of data from only one, like a Google or an Amazon, or can be mixed?
No, when I talk about spotlight, it is what data you are giving. It doesn't have to be Amazon. It doesn't have to be Flipkart. It is what you are giving as for it to train on.
Okay.
Specifically what you're
And
telling.
it wouldn't matter, which model I use, right? By which
wouldn't
company, as
You can use anything. Let me show you, let me show you previously here. See, Distill Word is Hugging Face's own, like BERT, whatever is there, it's all Hugging Faces. But then you can see there's something called as Process AI. And if I show there is translation, if we say translation, see, Helsinki is it has, where did that go? It has complete information on where this project comes from. See, Opus README. It also gives you like proper details as to where they have sourced everything from as well. So Helsinki, see, there's Facebook's NLLB one as well, where they tell you here are what are the metrics for the checkpoints. Checkpoint is basically what so this is a large model. You can't download this large model on your small computer, right? Your computer has particular capacity. So what it does, it takes like a snapshot, like a half of it. So it then stores that on your computer. And then it uses these, like you can see here in my, yeah, see, it downloads all these and then stores them as a cache. You know how cache works, right? Okay. So just it stores as a cache, and then whenever you run this model again and again, it will not download every single time. It will just use this from here on your system. So when you go back to Hugging Face now, so see here, they tell you what are the paper. And you know, one thing that I really like about this is they show you what's the carbon footprint detail as well of each and every single model, which is really amazing because there is a point till where you can exploit your planet, right? After that point, you have to start being conscious. We'll be like, okay, yeah, ChatGPT is there. We'll ask every single small question to it and we'll just overuse it as much as possible. But you know, just to run one question on ChatGPT, it takes about 80 million gallons of water to process it. So imagine how much goes behind it. So that's the whole framework and process that's there. We need to be aware of that as well. So carbon footprint is one of the amazing features that's present here. So essentially, when talking about transformers model, like I'll explain it in the most simplest terms as possible. Say you want to build, you've all played with Legos, right? The building blocks, particular, not literally Legos, but any building blocks thing. So before you start building it, or this might be just me, but before I started building a huge building directly, what I used to do is I used to classify these put all same colored blocks in one place, and then same shape and size, same what fits with one thing and what doesn't fit with the other thing. Like we used to make a differentiation of that and then start building our building. Your transformer just works that way. So what happens with your transformer is, say you want to build a building, so it's your work to do that. But look at transformer as a helper. So this helper does this encoding part for you, where it is already sorting everything. It has already sorted. This is called attention. Attention is all you need is a paper, and that's an amazing paper for those interested to read it. So this is called attention. So what it does this. It does the classification. It sees what piece goes with what piece, what are the different classification it has to understand. It understands everything in that, and it does the classification and keeps it. That's the encoder's work. Now, decoder's work, what it has to do is it has to identify these pieces and give you these pieces to build this particular castle of yours. Say you want to build a castle, then you want to do the foundation first, or you want to do the gates first. So they're like this particular pieces that go together. The decoder tells you, okay, these are the things that you put together, and then finally your castle is done. So you have attention, encoder, and decoder. These are the two main important things of a transformer architecture. And the third one is no rules. So essentially now we are just seeing that there is a distilled word case for translation. There are different models like this. This is just made easier for us. But initially when these are properly trained, what they are trained on is just a large corpus of language. And large corpus of language, how it is trained is, say if I say I am Nidhi Ashok, okay, and I, Ashok, Nidhi, am. You will be able to say immediately which is the correct sentence and which is not the correct sentence. This also works the same way. It just calculates the probability that I am, the word am comes after I, Nidhi comes after am, and Ashok comes after Nidhi. The proper order of these words is calculated based on probability. And this has been done. Obviously, these are small transformer architectures. So these are done on very specific corpuses. So a lot of books, a lot of different, like I said, Amazon, Flipkart, reviews, all these are done. Probabilities are calculated and stored. And then these are converted to whatever requirements are there, like translation task. This is like putting on the spotlight. So initially it is not trained with any rules. It's just learning the probabilities. That's all. Probability of one word after another. It's only learning that. So there is no rule behind that at all. Initially there were rules like n-gram, like I said, just when we initially started this, there's an n-gram. So there will be two words before it, one word after it. There was a rule like that. But in this case, there's no rules. So this is how even your large language model, that is your chat GPT, works. But the scale of it, so it's trained on the whole of internet. So it is not whatever was available openly, it is trained on it. So there was no barriers over there. That's why that's called a large language model. It's essentially, again, it's a transformer model. So this is about transformers and hugging faces. I'm open to questions now.
Yeah, in the chat, Nidhi, there are quite a few.
Okay.
So
I think she already answered the first one that I had put in. So
Okay.
maybe
So
Miss
these are
Aditi can.
LLMs. Are they similar to OpenAI's chat GPT model? Or yes. Essentially, yes. These are LLMs, but LLMs are on a bigger scale. These are just small scale. This is like classic. For example, there's one from Stanford, I believe, or or UCLA. One of these universities, they have a corpus which has trained on all the classic novels. Whatever classic novels it could find, they have trained on that. That also will be a transformer itself. But LLM has gone above and beyond. And while they are all generally applicable, do some models work better for certain use cases than others? Yes. So that's why, as you see here in models chart, they have been specifically separated into text classification and then question answering, translation, conversational. So these have been again further specified. So conversational will let you build a chatbot, and translator obviously helps you do translation. Then you have text generation. Text generation is like your prediction. So if you decide, you train this will be like chat GPT does it, right? You can ask it that in Shakespeare's words, write me a poem. So when you do that, it generates text. So it understands it has to go to Shakespeare's data and try to figure out how there the word is connected to each other. What are the probabilities of the word with each other to occur together? And based on that, it generates new texts. So that's your text generation part. So that's why there are some models that work better, and you can check any of these. There's like Meta.
And would these, these are based on, they're separated according to task, but would they also, have the same efficacy for different industries or different fields, like subjects, or that would, it would depend which model you use?
That actually would have different efficacies as well, because if you train your model on a classic literature uh, thing, and then you ask it to answer scientific questions, it might not work very well, right? Because it has no previous awareness of whatsoever going on in science. It will just answer your question. That's called hallucinating. It happens with chat GPT also. It will answer your question very confidently, but it's just generating text. It doesn't know what it's answering. It'll just find one related word, and it'll just keep on generating text. It doesn't need to mean anything. So for specific industries, specific data, you have to see what kind of data they have trained on and then use the model. So we have more questions, right? I'll stop sharing and look into the questions.
I think Miss Aditi also asked, and I think that's interesting to know, that how would you know how it's calculating the carbon footprint? What is the parameter on which it is calculating that?
It's the okay, this is actually, I know the answer, but quite tough to answer this because mathematically I can say this. So, whenever you're programming, you have seen that O to the N notations anywhere. Have you come across these? The efficiency of how fast a program runs. So when you're using, let's like very basic to the core, when you're using a while loop and it has to go through the loop again and again, so it is not an efficient program. But when you're using a for loop, that it's an efficient program because it enters the loop only once. When you're using a while loop, it comes back to that and again prints it, comes back and prints it. But when it comes to a for loop, it already knows all the parameters when to end. So it'll just get into the loop once. So when that happens, computing power taken in from this is less. So your time consumed is less. So computing power and time consumed, these two, when you can calculate the carbon footprint. This is one of the parameters, and this is
Yes, this would make sense. Yeah.
yeah. So end of the day, they're computing electricity.
Yeah, exactly. That's it's a direct generation of power, right? So, and the more power you use, the more. Okay.
The more
Yeah. Thanks.
time it takes. And then if Ms. Aditi is actually interested in the Hugging Faces platform itself has a paper by Sasha Luciani, who has very beautifully written in Hugging Faces blog site about this carbon footprint. So you can give a read through for that. I'm pretty sure she would have explained it better. So the difference between different models is the size and corpus of the data they are trained on. And Ridhima, could you please clarify?
Yeah, that's my question. And what else?
So you're saying like we want to figure out what are the difference between each models.
Like, I mean, if the function that they're doing is similar, what makes them different from each other besides the size and corpus and the kind of data that they train?
It also depends on what kind of parameters they have given. So parameters in the sense of have you trained a neural network? So in that, you would have seen that you're giving loss functions, you're giving many other optimizers, you're giving other batch sizes. So you have done this various experiments with these neural networks, and each model differs on these parameters as well. So when you're downloading this checkpoint, that checkpoint initially when you call this model, the model itself, so when you're going in much more detail, what I showed you was just a very, very small piece of code, simplistically. But if you want to go into details, then you
Did she freeze or did
No, she froze us. She froze.
I think let's just give her a minute. I'm sure her internet will just fluctuate. Okay, so while Miss Nidhi has got logged out because of a power cut, but I still just want to, for the sake of the recording, say thank you to her for the wonderful presentation. And I think it was so informative, not just for our students, but for some of our teachers as well. And I think lots of people are going to benefit from the simplified way she's explained this very, very technical concept in the newsletter, through the newsletter as well. And thank you everybody for showing up, and we hope to see you next month. Bye.